In this example, we're going to look at multiplying rational expressions. So a rational expression is basically a fraction that has variables. So it's a ratio of two polynomials. So we have an x or a monomial. It's a single polynomial, single term. Downstairs, we have a binomial. Over here, we have another binomial, and again, a monomial downstairs. So it's just fractions with variables. So don't overthink it. But what we want to do to multiply them, we want to always write our fractions or rationals in simplest form. And so the best way to do that is before you multiply it, it's easier to try and factor it all at the beginning, cancel those common factors, and then multiply. So you're going to multiply smaller values, and hopefully you don't have to simplify at the end. Now, I didn't even list it as a step here, but again, you may want to check. In fact, I highly advise you always check anytime you do any work, make sure it's in simplest form. That should really just be simplest form. So that should just be something you do anytime you do any work. Always make sure it's in the simplest form. You've answered the question. Always double check before you type your answer in if you're on the computer, or write it down on a test. So we're gonna go ahead and get started. I like to start off when it's something kind of simple like this. I'll put some lines here. So I'm gonna rewrite them, put them right back where they go. Anything like X, I'm not gonna change him. I'll leave him in black. Looking down here at my 7x minus 28. Now, I'm going to have to do some work on that expression. So I'm going to bring it. I'm going to take it over here. Just give myself a little room when I need to multiply in a minute. So I have 7x minus 28. I believe I'm double checking it real quick. You know what? I'll just scoot it back over. It's probably faster. Yes, 7x minus 28. Sometimes my memory is not always the best. I love paper for that reason. I love writing all my work down and showing it so that I don't have to try and remember things. Our brains have enough to do. So I jumped ahead. Looking at what we have a binomial expression. So to factor a binomial, the first thing, any type of polynomial, really, we always look for a GCF. So 7 and 28 have a common factor of 7. We're really just going to take that 7 out from both. You're dividing both by 7. If you want to show that division here, that's fine. Eventually, hopefully we won't have to. Dividing that 7, we're going to have an x minus 4. So we're going to replace our 7x minus 28 with 7 times x minus 4. So I'm just going to bring it over here, pop it right in. And now we're going to look upstairs. We have x squared minus 4x. I'm going to need to do some work on that one as well. Now, this one's pretty similar in nature. This does have a common factor. Oh my memory. X squared minus 4x. So x squared minus 4x. Okay. And so that's a separate little piece here. Again, GCF factor always first. There is an x present on both. So this one had a numerical GCF, this is going to have a variable GCF. And that's okay. We just do whatever the problem says. So we are going to divide both by x. For my first term, when I have an x upstairs and 2 upstairs, 1 downstairs, I'm going to have 1 x remaining when I cancel what they have in common. We're going to have a subtraction, and my x's will both cancel out here, leaving with 4. Okay? So x times x minus 4 is going to be the factored expression for that. So let's go ahead and pop it in upstairs. And my 3 downstairs, 3's prime. We're going to leave 3 alone. Now, this is always the fun part. We get to cancel. I'm going to draw a line here just to make sure it's really clear what's what. Looking at what I have on my screen, I'm going to start any term that matches upstairs and down can be canceled. You can only use it once. So I have an x minus 4 with an x minus 4. Is there anything else you see that cancels? Okay. It's kind of a trick question, not really. There's an x and an x. Now, these are upstairs. We cannot cancel things that are on the same line. So if they're on different lines, you're canceling, just like fractions, right? Like if you have like a 4 over a 4, you can cancel it. But if you have 4 times 4, we're going to multiply. So they work very much like numbers that we know. It's always helpful to kind of think about it that way if you start to get confused. But what I'm going to do now, I'm going to put my line here, always put it in. That reminds me, I'm going across the top, go across the bottom. So x by x gives me x squared. So this is our product rule from when we worked with exponents. If you don't remember, just real quick, anytime you have the same base multiplying, you're going to add those exponents. So that's going to be 1 plus 1, which gives me x squared. So again, that's the product rule for exponents if you want to review that. And that's for exponents. We're going to see that a lot. We were using the quotient rule over here when we canceled. So the quotient rule just works the reverse. You're going to cancel out the one, be left with the other. So those are both exponent rules, if that's something that maybe you want to brush up on. Now, in my denominator, I have a 7 and a 3, so I will multiply that and get 21. As I said at the beginning, you always want to stop and pause. Is my answer in simplest form? Does my answer make sense? And I think it does. So once you have that, you should be good to go, but always double check to make sure you've canceled everything first.